So this is chapter 6, section 5, part 2. We're going to continue using our three properties of logarithms. We continue with the product property, quotient property, and power property. So just a reminder, when we expand, we add if we're multiplying to begin with. To condense, if we're adding our two logs with the same base, we can put it into one log by multiplying them. Same thing with division, but instead we are subtracting to expand. To condense, we divide. And then with our power property, we can take our exponent and just multiply it to the front to expand. So today we're doing the same thing, but instead of numbers, it gives us variables and logarithmic expressions. So we're just expanding them and condensing them. So using the same properties as yesterday. So it tells us we need to expand. So what do you think we should do first?
Subtract.
Awesome. For dividing, we need to subtract. So the ln of 5x to the 7 power minus ln of y. So I just subtract what's on the top minus what's on the bottom. And anytime you break it up, you need to include that log, or here it gives us ln, so we have to include that ln with each. Now we can expand this a little bit more because we have some multiplying going on and some exponents. So what else can we do to expand? Here we have 5 times x to the 7 power. So how would we break it up if we're multiplying? Add. So this would be ln of 5 plus ln of x to the 7 power minus ln y. What else do you think we could do?
Miss Carter, you said this is the part 2 notes, right?
Yep, the second half of what we did yesterday. All right, what else do you think we could do? Can we do anything with that exponent? Move it to the front. So it just goes to the front of the ln that it's attached to. Not the front of the whole thing, just the front of that ln. So we have ln of 5 plus 7 ln of x minus ln of y. That's our answer. All right, in example 5 and 6, we're doing the same thing. So how can we expand this? Awesome. Since we're multiplying 3 times x to the 4th power, we just add them together. And anytime we expand it, everything gets its own log. So we have log base 6 of 3 plus log base 6 of x to the 4th power. Can we expand it anymore? Awesome. We got to put the exponent up front. So we have log base 6 of 3 plus 4 log base 6 of x. How can we expand this? Subtract. Since we're dividing, we expand it by subtracting. So we have ln of 5 minus ln of 12x. What else can we do? If we have two things happening in here, how can we expand this? How? Separate them using what? If they're being multiplied, how do we expand it? Add them. So we have ln of 5 minus ln of 12. And then I'm going to put this in parentheses since we have that minus that's happening to everything in here. So then this is plus ln of x So since, you can leave your answer as like this, but since the 12 and the x are on the bottom, they're actually both being subtracted. So you could leave your answer like this one, or you can write your answer as ln of 5 minus ln of 12 minus ln of x. So if you leave your answer as like the highlighted one, you have to make sure you put that parentheses because the 12 and the x are on the bottom of the fraction. So either answer would work. All right, in the next example, we are condensing it. So we're bringing it to just have one log. So we have log of 9 plus 3 log of 2 minus log of 3. So what do you think we should do first? Combine the logs. How?
Log 2 minus 3. Make the 3 because of 3 log 2 exponent.
Awesome. We want to make this 3 an exponent. So we have log of 9 plus log 2 cubed minus log of 3. What else can we do to condense it? If we're adding them, how can we bring it together just to have one log? Multiply them. So this would be log of 9 times 2 cubed minus log of 3. And now we're subtracting. So how can we bring it together again when we're subtracting? Divide. So log of 9 times 2 cubed over 3. Once we get to this step, we want to evaluate what this number is. So how can we solve, not solve because we're not figuring out what the log of it is, but we just want to do the math inside where it's 9 times 2 cubed divided by 3. So what should we do first to figure that out? What do we have to do first? Awesome. 2 cubed, which would be 8. So this is 9 times 8 over 3. And then 9 times 8, which is 72, divided by 3, 24. So this is the log of 24. So that's our answer. So we condensed this whole problem up here just to be the log of 24. And these two things are equivalent. They're the same thing. All we did was condense it to 1. So anytime it says condense a logarithm, you're condensing it just to have one log. So it's only going to have that one word, log. All right. Any questions on this one? Got 2 more examples just like it. So how can we condense log of x minus log of 9? We're subtracting. Awesome. We're subtracting, so to bring it together, we divide. So log, what goes on top? X. X over 9. Can we simplify this anymore? Nope. So that's our answer. Let's look at 8. What should we do first here for number 8? Put the 3 as the exponent. What should we do next? Awesome. So we have ln of 4 times 3 cubed minus ln of 12. What else can we do? Divide. So since we're subtracting, we divide. So 4 times 3 cubed divided by 12. Now we just have to work out what's on the inside. So what do we need to do first here to solve 4 times 3 cubed divided by 12?
Multiply 3 cubed.
What's 3 cubed?
27.
27. So we have 4 times 27 over 12. 108 over 12. Yep. So this would be the ln of 9. All right, next we have our change of base formula. So we actually talked about this in the last section. So I know you guys are all pros at this by now. If we have log base c of a, the a goes on top, the c goes on the bottom. So the little number that's already down low goes on the bottom. And the same thing applies. You can either do log or you can do ln, and you'd get the same answer. So you could take the a, put it on top, and the c on the bottom. So either way works, you'd get the same answer. So evaluate log base 3 of 8 using common logarithms. So what goes on top here? The 8. And what goes on the bottom? The 3. So what's log of 8 divided by log of 3? You guys need your calculators for these. Awesome. 1.8. 9. Does it say how many decimals to leave it? Nope. So 1.893. We can leave it with 3 decimal places. All right. Again, we're doing the same thing. Evaluate using natural logarithms. What goes on top? So the log of 24 over, what goes on the bottom? Log of 6. Then we just put this into our calculator. Awesome. 1.774. Perfect. All right, we have 4 more examples on this page. Doing the same thing. What goes on the top here? Log of 8. What goes on the bottom? Log of 5. What do we get? 1.292. What about for number 10? What goes on top? And what goes on the bottom? Log of 8. What do we get? I got something different. 1.269. Number 11. What goes on top? Log of 9 over, what goes on the bottom? Log of 26. We just put that into our calculator. What'd you guys get? 0.674. And then last one, number 12. What goes on top? Log of 30. What goes on the bottom? Log of 12. What'd you guys get? 1.079. Everybody agrees? Good work. So these last 6 problems that we did, the 4 and then the 2 examples before, should just be a review because we went over the change of base in the last section we did and it was on your test. So hopefully you guys went through this in a breeze. All you got to do is put the big number on top, little number on the bottom, and put it in your calculator. And you'd get the same answer whether you did log of 8 over log of 5 or ln of 8 over ln of 5. You'd get the same answer. So you can pick whichever one you'd like to use. So we got the last slide, which is pretty much the same thing, but you're not going to have any word problems, so we're skipping this. So there's no word problems in the homework. There won't be any on the next quiz or test, so we're skipping this one.